Hi, my name is Jeremy Dahl.
I'm Ashley Fabrico.
And we are taking general chemistry at Kapiolani Community College. For our project, we decided to make biodiesel. For this experiment, you'll need 0.1 normal potassium hydroxide, isopropyl alcohol, a ring stand, 10 milliliter burette, 250 milliliter beaker, stir bar and plate, phenolphthalein, and your biodiesel. Today we will be doing the free fatty acid test on the biodiesel to determine the amount of acid remaining. The first step is going to be the blank titration procedure. We're adding 50 milliliters of isopropyl alcohol to the 250 milliliter beaker, and we're using a graduated cylinder to measure it. Here we have our 50 milliliters of isopropyl alcohol, and we're now going to add this to the 250 milliliter beaker. Then we're going to add 8 drops of phenolphthalein indicator. So next we're going to add 0.1 normal potassium hydroxide solution inside our pipette again. Remember to make sure that the pipette is closed before adding any solution to it. It never hurts to put a beaker underneath there, just in case. There we go. Now that the pipette is filled up, we took note it's currently all the way full, so we record that as 0. Now we're going to add some solution into the isopropyl alcohol until it turns to a pink color. So we'll put the stir bar in our solution and go ahead and set it on the stir plate. We're just going to put 1 drop in and see if it changes color. Since the first drop of potassium hydroxide turned the solution a bright magenta color, we will record the B value in our tables as 0 for our calculations. For the second part of our procedure, you need to have 20 grams of the biodiesel weighed out. Record the exact weight in the notebook. In addition to that, you also need 125 milliliters of the titration solvent, isopropyl alcohol, with 8 drops of phenolphthalein added to it as well. Next, we're going to take our 20 grams of biodiesel and our 125 milliliters of titration solvent, add them together, along with the stir bar in there. Then you're going to put that on the stir plate and begin to stir. Now we have our burette filled with 0.1 normal potassium hydroxide solution, just as before. Make sure to note how much your initial reading is on the burette. Once again, our case is 0. And we're going to add solution until it turns a bright pink and stays for 30 seconds. So it's been over 30 seconds. You can see our solution is still a bright pink magenta color. We noted the amount of potassium hydroxide it took. It was 0.15 milliliters. And we're going to record that as the value A for our calculations. In order to calculate the total acid in the biodiesel, you'll first need your A value, the amount of titrant used to change color, is 0.15. The B value is our blank. The normality of the titrant is 0.1 normal. 56.1, the molecular weight of the potassium hydroxide, and 20 grams of biodiesel. We had 20.08. So, to calculate, you simply take the amount of titrant required to change the color in the sample, subtract the amount of titration used in the blank our case was 0. Multiply that by the normality, and then by the molecular weight of potassium hydroxide. Divide that by the weight of the sample. This will give us the milligrams of potassium hydroxide per gram of sample. We got a total answer of 0.0419. After sig figs, that becomes 0.042, which is under the ASTM standard of 0.5. The free fatty acid content calculation is the same as the total acid number calculation, with the exception of the molecular weight used. In the total acid number, it was 56.1. In the free fatty acid content, we used 28.2 for our molecular weight, as opposed to 56.1. We will use the same A, B, and W values as in the total acid number. Multiplying all of this out gives us a final answer of 0.021 for our percentage free fatty acid in the sample.